So first we're going to take d of dq of both sides, and you'll come in dp over dq, which is what we're looking for, which is equal to d over dq of q sine of q over q squared minus 1. So to take the derivative of this part, we would need to use something called the product rule, and also the chain rule, but we're going to start with the product rule. And how the product rule goes is that once you're taking the derivative of two different functions, you can say q, this whole top can be one function, this whole bottom the other, or numerator, denominator. If you want to take the derivative, let's say d of dx of u to, let's say x times v of x, this will equal u prime of x using Newton's notation, u prime of x times v of x plus v prime of x times u of x. So our first step here is to pick out u, and we will say u is equal to q sine of q. Sorry, I want to put parentheses here to clarify. And u prime will be what? Well, we actually had to use the product rule again because you have two different functions here, q and also sine of q. So we come over here, we could say u, we'll use u again, is equal to q, u prime is equal to 1. V will thus equal to sine of q, and v prime equal to cosine of q. And thus, using the product rule here, u prime will thus equal q cosine of q times, or plus, excuse me, sine of q. So we went through almost, not a tangent, but a secant, where you get that joke, I don't go off of tangents, I go off of secants. My bad, I have bad puns. So we went from here and we realized that we couldn't just take the derivative of this, we had to use the product rule times 2, and took it all the way over here. Used it again to get u prime. Now we can find v, and the v here is q squared minus 1 to the negative 1 power. V prime, thus using the chain rule here, we equal negative this quantity of q squared minus 1 to negative 2 power times 2q. And now coming back to our original function, we'll say dp over dq is equal to u prime v, which is u prime, u prime v, I'm going to switch these, so it'll be sine of q plus q cosine, oh hold on, I'm sorry, seems that we're going to get a little bit messy here, but we're going to use some of the space. What I'm going to do here, try out and put it right here. So dp over dq will equal to u prime of x, or in this case u prime of v times v of u prime of q times v of q, which equal this, sine of q plus q times cosine of q over v, which is q squared minus 1. And that added to negative 2 q squared sine of q over q squared minus 1 the whole quantity cubed. Now this is technically your answer, but what we're going to do next is simplify, and this will make the problem seem, we really just want to get this into one fraction. So our first goal is to make the denominators equal, and you can see here that we're missing a q squared minus 1 to make this denominator equal to this one. So what we're going to do is multiply this fraction by q squared minus 1 over q squared minus 1, which is essentially equal to 1. And this allows us to change the denominator here. So once we do that, you will get the quantity qu minus 1 times sine of q plus q cosine of q over q squared minus 1 squared minus, I took that negative sign there, 2q squared sine of q over q squared minus 1 the quantity squared. And thus we can add both fractions together, and you'll get dp over dq to equal q squared minus 1 times quantity sine of q plus q cosine of q minus 2q squared sine of q all over q squared minus 1 squared.